So today we're going to continue talking about primary education and how to improve K through 12 schools in the United States. And so you'll remember in the last lecture we talked specifically about reducing class size and the effect, the causal effect that that has on students' test score achievement and long-term outcomes, and we found that having smaller classes can actually be quite productive in improving students' outcomes. Today we're going to turn to another key input in the production of education, which is the quality of teachers. So the way in which you reduce class size is by hiring more teachers. And of course, as you'd think about intuitively, the impacts of a change in class size are going to depend greatly upon the quality of the additional teachers you hire. So it's very important to think about what the impacts of teacher quality are, just as we tried to think rigorously about what the impacts of changing class size are. And so I'm going to talk about, in this lecture, a series of work that uses big data to study teachers' impacts. And so I'm going to start by talking about some work with my colleagues John Friedman and Jonah Rokoff, in which we take a big data sort of approach to study teachers' impacts, where we first start from data on all kids who went to New York City public schools between 1989 and 2009. So that's 2.5 million kids who, over the period that we're studying, have written 18 million tests. So this huge data set on which classroom students are in, which teachers they had, what their test score achievement was, and so forth. And then, as we've done with a number of other studies, we link that information to the information from tax records so that we can look at kids' earnings, college attendance rates, teenage birth rates, and various other outcomes many, many years later. So what you can do with this linked data set is ask a question like, how does the quality of your third grade teacher affect how much you're earning when you're 25 or 30 years old? So in order to answer that question of how teacher quality affects students' later outcomes, the first thing we need to do is have some measure of teacher quality, some way to say a teacher is higher versus lower quality. And so the measure that we're going to focus on here is one that we can construct systematically on a large scale in these data, but also is extremely relevant from a policy perspective. And so some of you might have heard about these measures. What we're going to look at are what are called teacher value-added or test score-based metrics of teacher performance. So there's a very controversial debate about the use of teacher value-added measures, which I'll talk about in a second. But first, just to define what these measures are, the fundamental concept is really very simple. So what we're asking is how much does a teacher raise his or her students' test scores on average? So for example, if I'm a fourth grade teacher, we'd compute my value added essentially as my students' average test scores at the end of fourth grade minus their average test scores at the beginning of fourth grade or at the end of third grade. So basically, what is the delta from the point at which I started to teach them to the end of the year in terms of students' average test performance? So there's some more complicated statistical details in the background where we try to adjust for noise in these estimates and where we try to control for differences in student characteristics and so forth. But in a nutshell, that's basically the concept that people are going for with these measures, okay? So, intuitively, the way to think about it is if my students if their test score performance is much higher at the end of fourth grade than it was at the beginning of fourth grade, then we would say that I'm a high value added teacher. And if in contrast, some other teachers' test score performance at the end of fourth grade was much lower on average than at the beginning, then we would say that person is a low value added teacher. Okay, so as I was saying, these value added metrics have generated a controversial and quite politicized debate about evaluating teachers, in particular about whether these are good measures to evaluate the performance of teachers, whether you should be evaluating teachers at all on their impacts, how you should be measuring teacher quality, and so forth. And while there's a lot of political rhetoric and to some extent, I think, ideology involved in these debates, in my view, at its core, from a scientific perspective, the debate really revolves around three fundamental statistical issues, which is what I'm going to talk about in the first part of this lecture. I'm going to structure it around these three statistical issues. So the first concern that a lot of people have is that there might be potential for bias in these measures of teacher quality. So in particular, people ask, do the differences in test score gains across teachers capture the causal impact of that teacher, which is what we're really going after, or does it just capture differences in the types of students that different teachers happen to get? So if you happen to get students who are really hardworking and end up getting really high scores at the end of the year, then your value added is going to look high. And if I happen to get students who, through no fault of my own, end up not working as hard, then my value added is going to look low. And if we're going to do things like pay teachers or evaluate teachers on the basis of these measures, it would be unfair if I'm being penalized for the mix of students I happen to get, and you randomly happen to get a better set of students, right? That kind of variation, that sort of bias would be problematic. So the fundamental question there is basically one of sorting versus causal effects. How much of the variation in teacher value added that we see in the data when we construct these statistics is driven by the teacher's effect versus differences in the types of students that teachers are getting systematically year after year. So that's question number one, how much bias is there? The second question that generates debate is basically driven by a lack of evidence on teachers' long-term impacts. So suppose we resolve the first question favorably and we conclude that there is in fact not a lot of bias in these measures of teacher quality from a test score perspective. You might still ask, okay, that's fine, you've identified teachers who are really good at raising test scores, but are these teachers who raise test scores actually good at improving students' long-term outcomes, or are they just good at teaching to the test? So presumably, what we care about is identifying teachers who are actually going to help kids succeed later in life and not just do well on standardized tests. So a bunch of critiques of these value-added measures is that they just pick up, test score performance, maybe not anything that really has meaning in the longer run. So that's a second issue that we will try to tackle in the data. The third issue, which is distinct, is that there's a concern about instability of these value-added estimates. So ideally what you would do is observe a given teacher teaching many, many classes year after year, and then see if systematically they tend to improve student achievement versus not improve student achievement. In practice, you don't have that luxury. You're trying to evaluate teacher performance early in their career, typically after they've taught for only maybe 2 or 3 years. And lots of people complain that, oh, 1 year I had a high value added rating, but then next year I had a low value added rating because just through random chance, the 25 students I happened to teach had very different characteristics. And so even if you conclude that in large samples, these teacher value added estimates would be unbiased, and if they are good predictors of later outcomes, you might worry that when you only have a few classes of data, these estimates are going to be too unstable to really be useful inputs in evaluating teachers. And so that's a third set of statistical issues that we're going to try to tackle with these data. Okay? So what I'm going to do now, is, if those questions are clear, is just go through and sequentially answer each of those questions and then come back to the broader policy issue of, what are the impacts of teachers on students' outcomes? How important is teacher quality versus something like classroom size? All right, so as always, when we think about measuring any causal effects, as I've mentioned a few times in this class, it's useful to first step back and ask, what's the ideal experiment that you'd want to run to answer the set of questions you've laid out? And in this case, what you'd want to do is randomly assign students to teachers with different levels of value added, right? You identify with historical data some teachers as being high value added, some teachers as being low value added, and then you take a fresh set of students, randomly assign those students to teachers, and see what happens to their outcomes. Now, lacking the ability to actually run that experiment in practice, what we're going to do instead is use a quasi-experimental approximation to that ideal experimental design. And the idea of this quasi-experiment, which is really the fundamental idea of these two papers that I'm talking about with Friedman and Rokoff, is that we exploit the fact that there's a lot of turnover in teachers across school years. So you all probably experienced this in your own schools, where one year there happened to be a teacher teaching in a given grade, but then next year that teacher switched to a different grade or went on leave or changed what they were doing for some reason. And that sort of variation in which teachers are teaching, say, 4th grade in a given year in a given school, we'll show in a second, effectively looks like it's sort of random from the student's perspective. So if you look at, a high value added teacher entering a new school in a given year, you can effectively compare students' outcomes before that high value added teacher entered versus after. And that's almost as good as an experiment because from the student's point of view, when that teacher happened to show up is essentially random. Okay? So the methodology that I'm going to use to do this analysis is called an event study design. It's an approach that's really useful in this context and is useful in many other contexts as well. And so I'll go through it in some detail in the context of the following example. So let's imagine you're tracking a given school in New York City over time. And let's say you're looking at 4th graders in the school who get to 4th grade in different school years. Okay, so they're 4th graders in 1993, 4th graders in 1994, 4th graders in 1995, and so on. And so these are each kids born in different years, right? It's different cohorts of kids. So what we're going to do is, in this example that I'm giving you, look at average test scores for 4th graders in this school, and we see that they're kind of bouncing around the median, around the 50th percentile. And then what happens in the school at the end of the 1995 school year is that there's a new teacher who comes in who's rated based on historical data in the top 5% of the distribution in terms of their teacher value added, in terms of how much they're improving students' test scores, okay? So now, just as a note, I'm describing this in the context of a specific example with a single school, but actually what we're doing in the data here is averaging over thousands of such events to generate the plot that I'm showing. And I'll come back to how we do that in a second after describing this example in a more intuitive way. Okay, so we're tracking test scores over time. New school comes in at the end of the 1995 school year. So what happens to test scores? They immediately jump up and they continue to stay high as this teacher continues to teach subsequent cohorts of kids in the school. Okay, so that looks like there's a significant causal effect of this new high value added teacher coming in on raising the average performance of students in 4th grade in this school. Now, naturally, thinking back to the experimental design analogy, anytime you have an experiment, you want to have a treatment group where you change something, in this case, the entry of the new teacher, but you also want to have a control group to make sure that nothing else changed at the same time that might be confounding your analysis. So in this context, what's a confound you might think about? You might worry that when this better teacher came in, maybe that was correlated with other changes in the school where they got more resources or the principal changed other things in the school in some way that benefited kids, and maybe this is not all the causal effect of the teacher. So you'd like to have a control group to assess whether this really is the causal effect of the better teacher coming to 4th grade. One natural control group that you might think about is to look at test scores for 3rd graders in each of these years. What's the logic? If the better teacher came in and started teaching in 4th grade, they should improve achievement at the end of 4th grade, but they shouldn't have any impact on achievement in 3rd grade, right? Because those students haven't had the better teacher. And so if you plot 3rd grade test scores, you see, in fact, they're totally flat around the point when the new teacher comes in 4th grade, showing you can think of this as kind of a placebo test, or showing you that the control works in some sense. It's not that things are just generally improving in the school in some diffuse way. It actually works exactly in the right grade where the better teacher came in. Now, this holds not just at the grade level, it also holds in a subject-specific way. So you can show that if you get a better math teacher, for example, math scores go up, but English scores do not. Conversely for English, et cetera. So there are lots of comparisons you can do like this to convince yourself that this really seems to be the causal effect of this better teacher coming in. Now, a quick word on methodology. Why is this called an event study design? So while I've labeled things here in the context of a specific school and specific school years to make it easy to understand, what we're actually doing in the background is taking many cases, there are about 2,000 cases in the data, where a teacher comes into a new grade in a school who's in the top 5% of the distribution. We're calling the year of entry, the year of the event in the terminology of this literature, call that 0, and then basically think about time relative to that year. So there's the year before entry, that would be -1. There's the year after that teacher enters, that would be +1. That would correspond to 1994 and 1996 in this particular example, right? And so you basically renormalize the point of entry to be 0 for all of these 2,000 different events. Because in some schools, the better teacher might have entered, as in this example, in 1995. In other schools, it could be in 1992. In other schools, 2000. So we're going to basically take all of those events and stack them on top of each other, and then take an average in the year before entry, the year 2 years before entry, the year after entry, and so forth, to construct that plot. So that's what we're doing in the background to generate this graph, and then translating it back to a specific example to describe it in a simpler way. Okay, any questions on how this actually works? Yeah. Yes. No, all of this data is at the school level, exactly. So good clarification. So think of this as we are taking a given school and then looking at a teacher who enters, in this example, in 4th grade in that school. And then we're looking at the average test scores of 4th graders and 3rd graders in that same school. That's the key thing. Anybody else? Yeah. No, so we do that in middle schools. So it doesn't work in elementary schools, so we actually show that as well. So in elementary school in New York City, kids basically, they take math and English from the same teacher before 6th grade, okay? And so there, value added tends to be correlated across subjects. So a teacher who's better at teaching math also tends to be better at teaching English. So if you look at math value added, it's also going to affect the English test scores because the same teacher is teaching you English better. But if you go to middle school, you have different teachers in 7th and 8th grade for math and English. And that's where we do that placebo test, where if you have the better math teacher come in, math scores go up, but English scores don't in middle school. So it works exactly the way you'd expect.
So, is it the case that when you have a good math teacher, they're only adding 2 years?
Yeah. Yeah, so a further point that implies is there doesn't seem to be a huge spillover effect across subjects. So teachers who are good at teaching you math don't seem to have big effects on English, and vice versa. My suspicion is that there would be bigger spillover effects across closer subjects, right? So I bet if you had a better math teacher and we were looking in high school, your physics or science scores might go up, things like that. Yeah? I mean, some of that, I'm not showing you confidence intervals around these lines. So there is going to be some, just like you see in the 3rd grade series, there's just some fluctuation. So why does that happen? You happen to have a year where the kids do really well or not. So, you shouldn't read into this as like, this is the exact truth. Coming back to what I've talked about in earlier lectures about standard errors and confidence intervals, if we were to repeat this analysis a bunch of times, you're going to get slightly different looking figures. What is very clear, though, and you can just see visually, is that jump from 1995 to 1996 is very unusual, right? You don't see any other such jump on the graph, which, you can then formalize that and ask, what is the p-value for the hypothesis test? That's not a significant jump, and it's very low. But I wouldn't read too much into the other jumps. Anybody else? Okay, so this is one extreme example, the favorable example, of a really good teacher coming in. This also works totally symmetrically in the opposite direction, where if, unfortunately, you have this teacher here who doesn't want to be there and is in the bottom 5% of the distribution of value added, that teacher immediately pulls down test scores relative to the prior grade after coming in. So I was giving you the example before of the upper tail. It's totally symmetric in the lower tail. It's actually completely linear, basically, across the distribution. So it's not just about the very best teachers having a positive impact. The lowest rated teachers also have a relatively negative impact, and then it's kind of continuous throughout the distribution. Yeah?
Why are the scores so high relative to the other, like before they were hovering around 50?
Yeah. So part of this is the selection of where these teachers are entering, right? So where you have good teachers entering might be different in the base years from where you happen to have the lower value added teachers entering. So this relates more generally to, I wouldn't think too much about the levels because there's going to be a selection pattern in that in terms of where these teachers are coming in. That's why we're so focused on the change exactly around the point of entry, right? That more broadly points out that you don't just want to compare across schools because there are lots of differences across these schools that might generate differences in scores. Yeah? Yeah, I mean, so, you're right, there seems to be some variation there. Part of that, you do enough of these things, there's going to be some fluctuation again because of noise. The thing that's really identified, it could well be that other things are changing in the school at the same time. So I actually think in this case, and I remember we spent some time thinking about this, some of these schools are on sort of a downward trend in terms of resources. So it's not that things are perfectly stable. But the key thing to focus on is that there's a big gap that emerges between the solid line and the dashed line after the entry. That's the thing that really reflects the causal effect. So you raise a good point. You wouldn't want to necessarily conclude that the entire drop in the blue line is due to the causal effect of the teacher. That's why it's actually useful in this case to have the control. The control is not totally flat, perhaps, in this case. Yeah. Okay, so what do we learn from that sort of exercise? What's the point of it? The big picture point is that students assigned to higher value added teachers generally have higher test scores. And if you quantify that more systematically, I was just showing you a couple of graphs, but if you run a regression of students' test score changes on the change in teacher value added driven by entry or exit, you find that being assigned to a teacher who is predicted to raise test scores by 10 percentiles, that is, who is 10 percentile higher value added teacher, such a teacher does in fact raise students' scores by about 10 percentiles. The estimate turns out to be something like 9.5 percentiles. So why is that not a circular or tautological statement? What that's saying is, if I estimate value added in observational data, where there's no random assignment of students, and I find one teacher is 10 percentiles higher value added than another, the vast majority of that difference reflects a causal effect, as shown by the fact that if I randomly assign or quasi-randomly assign a new set of students to those teachers, I get about a 10 percentile point difference. That's the important result there, okay? So this is not fundamentally about selection. It's actually, on average, about the causal effects of teachers. So that answers the first question that I laid out, that bias doesn't seem to be a huge deal in the construction of these measures. Okay, second question. So we've shown that these measures are not strongly biased. Now let's see how they're associated with later outcomes beyond test score achievement. So what we're doing here now is taking our teacher value added measure on the x-axis from the lowest value added teachers, the bottom 5% on the leftmost dot, to the highest value added teachers on the far right. And now we're going to look at various outcomes 15 years later. So we're talking about like third grade teachers here. So 10, 15 years later, look at things like college attendance and earnings and so forth. So you can see that kids who were assigned to a higher value added teacher in third grade are significantly more likely to attend college than kids who are assigned to lower value added teachers. What is the gap? It's about a 2 percentage point difference in your probability of attending college. Is that a big effect? Again, think back to the logic that I laid out in the last lecture. This is the causal effect of having a higher value added teacher for a single year. So imagine now you have a higher value added teacher not just in third grade, but also fourth grade, fifth grade, and sixth grade. 2 percentage point bump in each of those years, that can add up to quite a bit in terms of differences in college attendance rates. So this, I think, for a single teacher's impact in a given year in your life is quite substantial. Suggests these value-added measures are actually picking up quite a bit of variation in what teachers do in terms of later outcomes. So that's college attendance. This is earnings. It's noisier because earnings are just much more variable than the 0-1 college attendance variable. But again, you can see fairly clearly that if you're assigned to a higher value-added teacher, you tend to have higher earnings than if you're assigned to a lower value-added teacher. And then to take a very different outcome, teenage birth rates. So if you have a lower value-added teacher, girls who have lower value-added teachers are significantly more likely to have teenage births than girls who have higher value-added teachers in elementary school. So along a bunch of dimensions, you see pretty significant impacts, not just on test scores, but also on later outcomes, okay? So that brings us to the second lesson, that this is not just about teaching to the test. Teachers actually seem to matter in terms of things that we would ultimately care about, things that we, upward mobility, things that we want to get from the education system. Okay, questions on that? Yeah. 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 So it's a good question. So let me tell you what we've done and what kind of the limit of our knowledge is. So we can do this analysis separately for teachers in 3rd grade, 4th grade, 5th grade, 6th grade, and so on. And you find roughly the same 1.5 or 2 percentage point effect in each of those grades. So that partly answers your question. So this is not just about a single grade where you see this effect. It seems pretty constant across grades. But I don't think it fully answers your question, because a further question you might have is, if you have a sequence of good teachers as opposed to just one good teacher, are the effects actually additive, or are they sub-additive, or maybe super additive, right? It could be that all you need to succeed is just one good teacher who inspires you, in which case, if you have 5 good teachers 5 years in a row, it may not have 5 times the impact. Or you could have a converse model where it really builds on itself, and if you have 3 good teachers in a row, that has a huge impact beyond just a 3x, right? So we don't have the right kind of quasi-experiment to generate that sort of variation, basically because we have this entry and exit one-off. If you think about it intuitively, you would need experiments where you have multiple pairs or triplets of teachers coming in and out. So I think it would be interesting to figure out how to get at that question of how additive these effects actually are. I'm saying as a rough approximation, given the effects are constant, if you assume they're additive, this would scale up to something pretty big. Anybody else? Okay, so that's the second lesson. So now let's think about what that means, given that we've seen these long-term impacts, what that actually means in terms of quantifying how important teachers are in the way that we quantified the value of reducing class size and got an estimate of something like a couple $100,000 in terms of future lifetime earnings for children from being in a smaller class. So when we say improving teacher quality, I think one intuitive exercise to think about is the following. So let's say we take the bell curve of teacher quality as measured by teacher value added estimates. Suppose we identify the teachers who are in the bottom 5% of the distribution of value added. And suppose we either give them some training or hire new teachers such that we bring them up to average quality. So, I think of this as like a reasonably feasible exercise. We identify the teachers who are in the bottom 5%, and you would think we should be able to get teachers of average quality. We're not asking for exceptional teachers, just teachers of average quality. What impact would that have, given the estimates that I've shown you? So that would increase the lifetime earnings of a single child by $80,000, given the estimates that I showed you. So, think of it as like it's a couple $1,000s a year of increases in earnings. Add that up over a career of something like 40 years. It's going to add up to a lifetime earnings increase of about $80,000 per kid. which translates to a gain of about $2.2 million per classroom, given that the average teacher in New York City classrooms teaches about 28 students. And so then that's 2.2 million dollars that we accrue over the next 40, 50 years, right, over the period that these kids are working. Now, as I've said before, from an economic point of view, money 50 years from now is worth less than money today. And so if you discount that money back, the future stream of payments back at a 5% interest rate, which is a quite high interest rate, you end up with a present value of about $400,000. So this would be equivalent at a 5% interest rate to giving you, to like writing you a check for $400,000 right now, making this sort of change in a single classroom in a single year. So the bottom line of that is teacher quality and potentially feasible changes in teacher quality can have quite substantial impacts in terms of kids' later outcomes, especially when aggregated over the many kids that a given teacher teaches. Okay, so that makes it look like these measures are potentially pretty useful for identifying teachers who can be effective. But this now brings us to the third issue that I had raised up front that people are often concerned about, which I actually do think is a more serious concern, which is about the reliability of these teacher value-added estimates. So the calculation I just did, the $400,000 gain, actually overstates the feasible gain because we don't actually observe exactly who the high value-added and low value-added teachers are. So what I assumed in that exercise is that we knew with perfect certainty every teacher's value-added. The only way we could know that is if each teacher taught like an infinite number of classrooms and we could see with perfect precision what that teacher's value-added is. In practice, as I was saying earlier, you usually have performance data for just a couple of years before you need to make personnel decisions. And value-added estimates based on just a couple of classes are going to be statistically imprecise because teachers who happen to have students who do well by chance will get a high value-added score, right? So there's going to be some luck of the draw in terms of which types of students you get, or you just happen to have a good year one year, or you didn't happen to have a good year. And so the next question then from a very practical policy perspective, and it raises some, I think, useful statistical methodology as well for you to know, is to ask whether this estimation error in these value-added estimates reduces the gains that you can actually get in practice. Okay, so let me walk you through how we can think about that. We can actually try to quantify how much we will lose because we can't perfectly measure each teacher's value added. So come back to this exercise where we're trying to identify the teachers in the bottom 5% of the distribution of value added, okay? So ideally, we would identify those guys in the bottom 5% highlighted in yellow. In practice, we're going to have to rely on estimates with a limited amount of data. And in particular, suppose we are only able to use data from 3 classrooms. Look at teachers who have taught for 3 years. So what we're showing here is, given the uncertainty in these estimates, what the true value added of the teachers who we identify, who we estimate as being in the bottom 5%, what their true value added, their true quality in some sense, would actually be. So notice that this red distribution here is not all concentrated on the far left, right? In particular, there are a bunch of teachers whose true value added is going to be closer to the median, which is 0 here, or minus 0.1 standard deviation. So they're going to be relatively good at like the 25th or 30th percentile, but whose estimated value added after 3 years is in the bottom 5%. So why does that happen? Those teachers happen to get a bad draw and happen to end up in the bottom 5% just because the students they taught, they just had a bad day on the test, or like for whatever reason they didn't end up scoring high on the test at the end of the year. So it is absolutely a fact that if you use estimated value added, you are in some sense going to make some mistakes. You were trying to identify the 5% lowest rated teachers, But in practice, you're not going to be able to do that perfectly, and you're going to catch a bunch of teachers who are at the 20th or 30th percentile. Now, one thing to note, though, is the critics of these measures often argue, this is extremely noisy. You might end up penalizing some teachers who actually were some of the best teachers in the school when you try to identify the teachers in the bottom 5%. You can see that's not really the case, right? If you look at the red distribution, there's essentially no mass above 0. That is to say, essentially no teacher whose true quality is above the median, above the 50th percentile, will get rated in the bottom 5% just because of random chance. That almost never happens. And that's because there's enough, after you've taught 3 times, you've taught 3 times 28, so something like 85 students, you're going to have enough information there such that if you were actually a pretty good teacher, it would be pretty unlikely that over 85 students, their average test score gains ended up in the bottom 5%, even though you were actually a quite good teacher. Okay, so what you learn from this is there is an issue, but it's not dramatic in terms of potentially getting it completely wrong, even with 3 years of data. Okay, so then what you can do is quantify how much of a gain you get when you have limited data to measure teacher quality. So in this chart here, first we're showing in the blue line kind of the hypothetical maximum gain you could achieve by implementing that 5% deselection policy that I described earlier. So if you perfectly measured teacher value added, how much of a gain would you get from replacing teachers in the bottom 5% with teachers of average quality? That's the $407,000 number. So then what we're plotting in the red is what is the gain you can actually achieve if you use 1 year of data to estimate teacher quality, 2 years of data, 3 years of data, 4 years of data, and so forth. So those numbers are lower because you're going to make a bunch of mistakes. A bunch of the people you think in the bottom 5% are actually going to be at the 10th, 15th, 20th percentile. But you can see that once you have 2 or 3 years of data, that number quickly reaches something like $250,000, okay? And waiting beyond that point really doesn't get you that much more information, all right? And so, the bottom line from that analysis is that I think value-added estimates based on a few years of data are sufficiently reliable to at least generate large gains on average. They're certainly not perfect, but they provide some information, okay? So even taking into account the fact that value-added estimates fluctuate depending upon which students teachers get, the gains from replacing a teacher with estimated value added in the bottom 5% with a teacher of average quality is about $250,000. It's less than the $400,000 gain you'd like to achieve if there were no measurement error and you could perfectly pick out the highest and lowest value-added teachers, but it's still, a substantial gain, right? It shows you that there's still some informational content in these measures, right? Questions on this third point? Yeah. Yeah, so the way you do it is this. So come back to this chart here. So for each case you look at, right, you can imagine, take all the teachers in the data, imagine I estimate their value added using only 1 year of information, only 2 years of information, only 3 years of information, and so forth, right? For each of those cases, you can draw a plot like this, which is to say, what is the true, we can recover based on our understanding of the standard errors of those estimates, what's the true underlying distribution of value added given the estimates that I see. And then given that, and I know the relationship between true value added and earnings, I can calculate separately for each of those years the average gain I'm going to get from the policy. So I'm glossing over some detail there in terms of how we use the underlying standard errors to get at this red distribution. But the basic logic is, for each of the different configurations of the data, you figure out how much noise you have in the estimates, how much it's varying just because of random chance, and how much it's actually varying because of true differences in teacher quality. Others? Okay. Okay, so we've talked about those three sets of findings. Let me now tie this back to the kind of broader policy debate and what I think we conclude from this. So in practice, like, why is this so relevant? As many of you might know, most school districts in the US don't use any performance metrics to evaluate teachers at present. In most districts in the US, most public schools, 98% or more of teachers get tenure within 3 years, and there's no performance evaluation, right? So once you get a job in teaching, unlike most other private sector professions in the US, where there's some evaluation, there's essentially no evaluation in the teaching system. Moreover, again, unlike the typical functioning of the economy in the US, pay is set purely based on experience, so it's just a strict function of the number of years you've taught, and not based on any performance measure. Not value added, not what the principal thinks of you, not what the students think of you, not any measure of performance. And so as a result, the teachers who are outstanding are not necessarily getting rewarded more financially than the teachers who are not doing as well. So this sort of evidence that we put out in this study has sparked, I think, renewed interest in thinking about whether that system makes sense and finding ways to recruit and retain the best teachers more effectively. And so just to give you a sense of how that's played out at a national level and a local level, you see here President Obama in one of the State of the Union addresses saying, we know a good teacher can increase the lifetime income of a classroom by over $250,000. Every person in this chamber can point to a teacher who's changed the trajectory of their lives. And so then the White House under Arne Duncan made a lot of efforts to try to increase performance evaluation and basically try to recruit and retain better teachers in US public schools. And then you see a similar thing in New York City in particular with Mike Bloomberg talking about similar issues. Another place where this is playing out, has played out and continues to play out, I think, in an important way, is in the courts, where there was an important lawsuit in the state of California based on the paper I just talked about called Vergara versus California, where they argued that differences in teacher effectiveness, which you could measure with these value-added measures, created racial inequity in in the LA school district, because minority kids tended to go to schools with lower value-added teachers than non-minority kids, and then that makes it a legal issue, right? Because the law guarantees equal access to education, and this creates a way to quantify the racial disparities that are created and so forth. So that case went through, it was decided in favor of the plaintiff at the LA local court and then got reversed at the higher level, but then more broadly has led to a series of reevaluations, both in the courts and in the legislative bodies more generally across the US, in thinking about whether one wants to change the way in which teachers are evaluated and retained and so forth. And so to summarize, I think these new data that I've been talking about here show that changing public schools in certain specific ways, like reducing the size of classes or improving teacher quality, can have quite large long-term returns. My general take, coming back to the poll question that I put up at the very beginning, is that it's clear that reducing class size can be quite valuable, but it's absolutely critical to hire highly effective teachers if you're trying to reduce class sizes. So actually on net, if I were to pick between having better teachers and smaller classes, I would probably pick better teachers. It all depends upon the magnitudes, right? So if you're talking about a dramatically better teacher, that's going to have much higher value. But teacher quality seems extremely important. And I think the key takeaway from what I've just shown you here is that there are quite large measurable differences in teacher quality. I think all of us have the intuition that teachers matter, but the point is it's not just that they matter in some way that you can't quite figure out, but it's actually quite quantifiable in the data. And so given that, I think it's imperative that we do more to retain and attract top teachers in public schools. And importantly, I emphasize this because this study and this work actually has been some of the most controversial stuff we've put out of our group, where lots of people think that we're advocating purely for lots of testing and value-added metrics and all that stuff, but that's actually not my perspective. My sense is that these measures give us one quantifiable way to move forward, but more generally, you should be trying to build better methods of evaluating the quality of teachers. It could be based on this test score stuff. That's kind of crude, to be honest. But beyond that, you could imagine using information like classroom ratings, student evaluations, what principals think, and these sort of quantitative measures can provide a useful input into that process. But I think the bigger picture point is that actually trying to figure out how you get the best teachers in our public schools can have enormous returns for the country and really improve rates of upward mobility, especially in disadvantaged schools. Okay, so any questions on this segment of stuff before I move on to slightly different things? Yeah.
How do you improve like actual teachers who are performing poorly and get them up to the median instead of
Yeah.
just hiring these good teachers
Yeah.
to improve their existing?
Yeah, so unfortunately, we don't really have a great answer to that question. So there are lots of teacher training programs that people have attempted over the years, and they have very mixed records of success. Nobody has found, kind of the magic formula for systematically training people. In fact, even more discouraging is when people try to ask, can you predict who the high-quality teachers are? Set aside figuring out how you change teacher effectiveness. Can you even predict based on like people's resume or observable characteristics? You find it's extremely difficult to do, right? And I think that sort of makes sense intuitively. Like if you all think about which professors are good teachers and you just look up their CV on their website, you probably wouldn't be able to guess. And it makes a real difference to just see someone teaching. And so what people have found, like in our School of Education, there's some really nice work being done by a professor named Tom Kane, where they're videotaping classrooms and trying to understand what effective teachers do better. And what you find is you can kind of tell when you see an effective teacher, but it's hard to codify the thing. And often, especially in younger grades, it's less about like, are you really good at explaining math, and more about, can you manage a classroom well, and do kids pay attention, and are there discipline issues and things like that. So I think it's not a great answer to your question because we honestly don't really know the answer yet, but it seems much more complicated than here is this training program that we just need to send all teachers to. Yeah.
Related to that question about the goal of maybe moving all teachers to the median, I could imagine that gets to the question of the general and partial equilibrium. Like if we're actually trying to move all teachers to the median, there's still going to be some that are in the bottom
Yeah.
percentile. So how does the value add model think about like overall impact, or like is there
Yep.
a threshold that you're trying to get at rather than
Yeah.
having the median?
I mean, the way I think about it is it's all just like linear. It's not about thresholds. It's just like better teachers help kids, like going from the 5th percentile to the 20th percentile to the 50th percentile to the 90th percentile. Anytime you have a distribution, there's always going to be a set of teachers in the bottom 5%, right? I mean, this is not some absolute thing. We're rating the teachers relative to each other. But I don't think of it, coming back to the answer I gave in the last lecture to a related question, I don't really think of this as like a rat race, zero-sum sort of model. If you have better teachers that help a given kid and you just improve the quality of teachers, those students do better. Now, it's true that at the end of the day, those students may be competing for a fixed set of seats at Harvard or whatever, and so there's going to be some diminishing return in general equilibrium. But my sense from kind of the broader literature is that generally the way education works is by improving the people's productivity, and they find better things to do. And it's not so much the fixed pie model where you had the high value added teacher and now you got the good slice of the pie and I don't get to have it. It's more like you're more productive, you're less likely to get involved in crime. You can see some of these impacts also don't have that character. Like think about teenage births, for example. You wouldn't think of obvious general equilibrium type of effects there, right? Or in the context of things like other outcomes. So.
I think I'd be more like the median might change year to year.
Yeah.
Like, what is the median of a good teacher? What is
Yeah, but and I think what you're getting at there is we don't have an absolute measure of teacher quality, but I think it's totally fine if the median goes up, if you had some way to measure the absolute level of teacher quality. and you're just shifting up the median, that's just going to lead to better outcomes for kids. So I think that's a good thing. Why do we not have an absolute measure here? Because if I were to tell you, that this teacher generates test scores of 75, like what does that mean, right? It makes more sense to think about it in a relative sense. Yeah. Yeah. Yeah, so DC did this in a big way under Michelle Rhee, where they started to evaluate teachers in exactly this bottom 5% thing. It's, to be blunt, it's like quite, people have very different views, right? So teachers' unions are not enthusiastic at all about this sort of stuff. Principals, people in kind of the education reform kind of view are very enthusiastic about this sort of stuff. And I think you can have legitimate views on both sides. I mean, I think teachers' unions say there are some teachers who are really good who are, if you just go strictly by these measures, they just get unlucky and then, they get dismissed or don't get the bonus or whatever. I think the most sensible way to use these measures is probably not just mechanically go by teacher value added, but use them as an input that you give principals. So if you think about like how a company works, you never make personnel decisions just in an automated way based on some algorithm. You use the algorithm, you use performance evaluation measures like sales or whatever as an input that the manager then uses to make a personnel decision, right? And so I find the view that you should totally ignore this data extreme, like how can it be desirable to just completely close your eyes to information that you might be able to use? But then how you use it, I don't think it's clear that you should just mechanically go by it. You use it in a thoughtful way, depending, if you have other signals that a teacher is extremely good, maybe you pay less attention to this sort of measure, right? Anybody else? Yeah, it's a good idea. I mean, it's a little bit like with the neighborhood stuff, looking at the neighborhoods that look really outstanding in terms of good outcomes and trying to learn from them. No, I think it's a good idea. I think you'd want to figure out a way to have scale, right? And identifying many such teachers and try to understand what their best practices are. I mean, the type of way you could do that is there are these awards for, best teachers in a state or in a school, things like that. You could try to understand what those teachers are doing. We certainly have not done anything like that in our own group. There may be work in education that I'm less familiar with where people have done qualitative studies like that, but it certainly seems like a plausible way to learn. Yeah. Yep. Yeah, so I think both of those phenomena are plausible. So actually, like stepping back a bit, whether or not you use these value-added measures in particular, I think one of the reasons, like you remember that early slide I showed which suggested that Finland had extremely good educational outcomes at lower expenditure than the US. So if you think about like anecdotally, if you talk to people about what's going on in Finland, for students who are excelling in school, like the top students, one of their goals is to become a teacher, right? So teaching is viewed as like a very desirable career. It's well paid, it's prestigious, it's highly respected. Unfortunately, in the US, given the current system, for whatever reason, teaching is not typically the position that, for instance, many of the students in this room are likely to pursue. There are very selective programs like Teach for America, which students at top colleges tend to do. But then the challenge with programs like that is they tend not to keep people in teaching for a long time, only for a couple of years, right? And so the reason I say that in answer to your question is I do think a shift towards a system where kind of teachers are treated as superstars and people who are doing a really good job are recognized for that, not just in terms of money, which is kind of the first thing you might think of from an economic point of view, but more generally in terms of social norms and kind of reputation of the system, all of which is hard to change. I think that can have a big impact on the influx of people into teaching, which has got to be a much bigger deal than figuring out, how you go from the 5th percentile to the 20th percentile within the set of teachers you have, right? If you can get more students like from colleges like Harvard going into teaching, that's going to have a really big impact. On the flip side, people sometimes talk about how this sort of system creates more risk. So if you're not sure how good of a teacher you will be, currently you have the kind of tenure system with no evaluation gives you some security. But if you have evaluation, that's going to create some risk. I think people are willing to tolerate that type of risk in most professions, and it leads to favorable selection. So I actually think it's a desirable thing, but that is a potential cost. Yeah. Okay, great. So the next thing that I'm going to do is talk about these issues from a very different perspective. So you'll remember when we started talking about primary education, we talked about two different ways to tackle the problem. One is government-based solutions, trying to figure out how we improve the public school system through changes in class size, teachers, et cetera, understand the production function. A different approach is to leave it to the market, like we leave many other problems. And so that's what I'm going to talk about. The last set of issues we'll talk about in the context of education. All right, so the idea here is just to leverage market forces by permitting school choice. And so what's the logic of this? It's the basic logic of how we think a free market delivers pretty good outcomes. The idea is that, like any business, if you've got a really good school, presumably it will attract more students in equilibrium, and other schools will have to kind of compete and improve their game in order to stay in business. That would be the standard market logic. So how do we don't actually have an explicit market for schools in the US, but we kind of go in that direction in two ways. The first is to have charter schools. These are schools that are publicly funded, but independent of the public school system. And then the second is a voucher sort of system, where rather than paying tax dollars and then having to use that money in your local school, you get a voucher from the government, and you can use that voucher at a private school or any school you want that you choose. Okay, so both of these are kind of moving in the direction of the market where you give people more choice and let schools maybe do whatever they want. Charter schools can innovate. Private schools are free from the regulations that public schools face. They're not constrained by the teacher regulations we were talking about, things like that. Okay, so broad question, very important from a policy perspective. Are private schools or charter schools better than public schools? Now, you want to answer that question. It's a question about causal effects. Again, as usual, you can't do the first thing you would think of, which is just compare outcomes, say, at charter schools and public schools, because charters in particular tend to be started in lower income urban areas and disadvantaged areas. Why are people starting charter schools? Precisely because they're unhappy with the public school options. And so that leads to a selection bias where the types of kids going to charter schools are different from the types of kids going to the typical public school. And so in order to make progress on this question, as in other settings, we're going to need to search for some random or quasi-random variation to be able to compare apples to apples. And so there's a quite strong literature that has developed in the past 5 to 8 years that has been able to make use of modern data to get, I think, pretty good answers to this question. So what these studies do is estimate the effects of charter schools on students' outcomes by exploiting the fact that many of them have lotteries for admission. So in particular, charter schools often have more applicants than seats. And so what they do in that case, if they're oversubscribed, is just literally have a lottery. So the lottery is great because it's literally, from a scientific point of view, it's very useful because it's literally an experiment. You just compare the people who won the lottery and the people who didn't win the lottery and see how well they're doing in terms of later outcomes. And so there are a set of papers written by Josh Angris and Parag Pathak at MIT and a series of other authors that get at these issues. So I'm going to give you an example from one of these papers, which compares the effects of charter schools and what are called pilot schools in Boston. So charter schools are exempt from all public school regulations. So for instance, they can hire teachers however they want, they can pay them whatever they want, et cetera. Pilot schools are like charters, but they're covered by the Boston public school regulations and in particular by teachers' union contracts. Both of them are financed in the same way. They're financed by payments from the student's home district. So if you choose to go to this charter, the tax payment that your public school would have gotten gets transferred to the charter or pilot that your kid actually attends, okay? So what are the causal effects of attending these schools? This is very straightforward to look at because they're basically going to compare the winners of the lottery to get into the Boston charters versus the kids who didn't win that lottery. And so on the left, you see the impacts of getting in by lottery into the charter schools. And so the blue bars are for English, red bars are for math. The dashed vertical lines are 95% confidence intervals. And the units here are standard deviations. So 0.2 means that you are 2/10 of a standard deviation of the distribution above the mean. So think of that as like an increase of something on the order of a few percentiles, something like 4 or 5 percentiles in terms of a test score gain for English, and then a little bit larger for math. And so what you can see here is that the kids who, through pure chance, got into charter schools are doing quite a bit better than the kids who ended up going to public schools. But interestingly, if you do the exact same analysis for the pilot schools, which are also these new schools that were created, but with the regulations kind of more within the confines of the public school system, you get absolutely no gain at all, right? So what they infer from that is that the flexibility that the charters have to potentially hire better teachers, structure things in different ways, is leading to significantly better impacts in this particular context relative to public schools. Okay, so this looks favorable for charter schools in Boston. Okay. Now, in subsequent work using the same kind of research design, they show that Boston charters don't just improve test scores, they also improve later outcomes like college attendance rates. And so as I was saying, the lesson they take away from that is that charters seem pretty good, pilots are no better than public schools, and so relaxing the public school restrictions through charters may actually be desirable. Now, there are many, many other studies of that type using lotteries, not just in Boston, but in many other cities across the country, many other types of schools and so forth. Without going into the detail of each one of them, the broad summary is that there are small positive effects on test scores on average, but there's a lot of variability across different types of charters. So when people often ask me, are charter schools better than public schools? And my response is always, it depends upon which charter school you're talking about, right? So there are some charters, like the ones that were started in Boston, that seem to be delivering pretty good outcomes. There are other charters you will find where they actually have worse outcomes than the public schools, right? There's no guarantee that the charter is going to be better than the public school. It depends upon what they're actually doing in terms of the curriculum and the instruction in that school. And so the general pattern that people seem to find, and it's kind of the consensus now in this field, is that so-called no excuses schools, which tend to be kind of academically rigorous schools where you have extra hours, you tend to have longer school days, a longer school year, pretty disciplined environment, academic focus. The no excuse kind of terminology is it's not that the students have no excuses, it's that teachers take the view that they have no excuse for any child kind of underperforming. Every kid, through sufficient rigor, can be brought up to the standard. Those types of schools that have that particular philosophy, there are a set of schools like the KIPP schools, for example, that are of this style, they tend to have the most positive impacts, okay? So the point here is that there are some charter schools that are pretty good, the market kind of seems to work and delivers better outcomes in certain cases, okay? Now, the idea of the free market is not just that it gives people options, but the whole concept of a free market economy is that market discipline will increase market share for the good performers, and eventually the weak performers will drop out. There will be this process of selection where extremely successful companies are going to, the better companies that offer better services are going to naturally capture more of the market over time, and others will disappear just through the force of competition. And so a very important question in this context is whether market discipline in the school sector does in fact lead to the growth of better schools and improvement in performance over time. And so there's a study by Rick Hanushek at Stanford and co-authors in which they analyzed that question by looking at how the quality of charter schools in Texas has changed over time. And so the key chart from their paper is this one, where they're essentially plotting, look at the upper left box, for example, labeled 2001. So what they're doing there is plotting the distribution of the quality of schools measured in the same value-added way. So the way we talked about measuring the value-added of teachers, you can also apply that to measuring the value-added of schools, right? How much did students' test scores go up when they attend a given school? And so the dashed line shows you the distribution of their value-added estimates for Texas public schools. So notice that that distribution is very sharply peaked around the median, meaning all Texas public schools are kind of similar to each other. Some of them are a little bit above average, some of them are a little below average, but there are none that are disastrously bad or extremely good, okay? Now the solid line here is for the charter schools in Texas in the relevant year. And so you can see in 2001, there's a pretty broad distribution for the charter schools, right? Some of them have pretty low value added, some of them have pretty high value added, well above the Texas public schools, and it's generally pretty diffuse. If anything, it looks like that distribution is centered. If you look at the peak of it, it's slightly to the left of the Texas public schools, right? So back in 2001, the average charter in Texas was probably a little bit worse for kids than the average public school. Now, the key focus of this paper is how that has changed over time. Is the market working? Is it weeding out the worst schools? Is it shifting up quality over time? And so you can see what has happened is that that solid line starts to become more and more concentrated over time. It starts to get more and more peaked. And in particular, those schools that were way down there on the far left at -1 standard deviations or below, really not doing well in serving kids, are not there anymore. They've either closed or they have much fewer students than they did in the past. So there's some shift upward, and in particular, reduction in variance in the quality of schools, exactly as you might expect to happen over time in any market, right? A different way to look at this, which is in some ways simpler and kind of gets at the key point, remember how I was saying the no excuses KIPP type of schools tend to be the ones that generate the best outcomes? If you just look at what share of charter schools in Texas follow the no excuses philosophy, that's gone up substantially. It's doubled since 2001. So it's a very simple way to say that schools in this market tend to be shifting towards the model that sort of seems to work, right? Again, suggesting the market is pushing things in the right direction. So all of that, I think, is pretty encouraging for the market-based approach. The charter school market's evolving in a positive direction. Better schools are gaining enrollment over time. However, as you saw in the previous charts, it's not like you've completely eliminated the dispersion. There are still a number of relatively low-performing schools, even 15 years after the system began. There's no kind of guarantee that you're going to solve all the problems automatically over time. Okay, so I think up to this point tried to quickly paint the favorable case for the market-based approach. You see some pretty good outcomes in some of these schools. Over time, those schools start to grow and so forth. So you might say, okay, from that point of view, that all seems pretty encouraging. Why don't we just go all in on that approach? Why do we continue to focus on public schools and improving public schools? I think there are three key limitations of market competition, of the pure private market approach. So the first is that markets generally function poorly when quality is not well observed. So I tried to explain how they gauge value added using test score data for those Texas schools, and so that's a pretty good stab at it. But ultimately, you would like to measure value added and looking at longer term impacts, looking at things like college attendance, looking at things like earnings. And all of those things are realized 10 plus years after the point at which you're actually, in some sense, buying the services of the school. So it's going to take a while to figure out which schools are really doing a good job in terms of getting kids to good colleges and so on. And in that type of setting, like why does something like Amazon function so well? You can tell immediately if you buy something on Amazon if the product is good or not, and you provide feedback, and then the market operates at a very high rate. Here, if you're going to wait 10, 15 years to actually figure out if a school is doing well or not, to really have a clear sense of whether it's delivering good outcomes, that's going to greatly limit the ability of the market to function well. A second problem that people often point out, the critics of the private market movement in schools, is a problem of cream skimming. So private schools, if you think about what their incentives are, they have no mandate to serve all students. In fact, they have an incentive to reject less qualified applicants. And so that can exacerbate inequality by leaving less qualified students behind. They're not able to get into these better schools. And moreover, they're now left behind in a public school that has fewer resources and perhaps weaker peers, because all of the better students now got selected out, cream skimmed out into the charter school. So you can see from an inequality perspective, if you have only a subset of kids going to charters, and it's the more advantaged kids or the kids who happen to be ahead in terms of learning, that can potentially be quite bad in terms of creating disparities. And a third problem is that markets tend to work well when you can rely on people to make good choices. Unfortunately, as we saw, for instance, in the affordable housing context, where people were not necessarily picking the best neighborhoods to live in, there's a similar problem here, where families, especially low-income families, don't necessarily choose the best charters, even if we know from the data the no excuses schools generate good outcomes, et cetera. So there's a nice paper by Justine Hastings and collaborators where they studied the introduction of school choice in Charlotte in 2002. And they show that once you give people more options, you would have thought that's a good thing. They show that low-income parents are much less likely to choose the schools that are delivering good outcomes than high-income parents. And so school choice in this context, because people are not making the best decisions, actually ends up amplifying inequality. And so for all of these reasons, my view is that it's not obvious that you actually want to go to a strict market-based approach. I actually think that you want to think about sort of a hybrid system where we now know, with modern data, how we can measure the impacts of these various different types of school systems. And so then when we come to kind of the big picture question, which approach is better, government or market-based, my sense is that the current constraints in the public school system, regulations on teacher hiring, et cetera, limit its effectiveness to some extent. But an unregulated market system, while it might improve outcomes on average, could deliver very variable outcomes across schools for different subpopulations and so forth. And so my guess is, the best system is some sort of hybrid that preserves flexibility within schools while offering uniform quality and resources across schools. And so, I think there's not a super clear-cut answer between those two systems. So that's it for today.